Hi, I'm on page 195 of your book. Let's take a look at that. We're going to be talking about exponential functions. And an exponential function, basically, they don't look like linear. Linear looks like a straight line. Quadratic looks like this, or like this. This is where you have x squared. This is a negative x squared. Negative x is a positive x, where your x value dictates what the line is doing. Okay, so I don't think we need this page. All right, so this is not in your book, but this is linear because it's just raised to the first. This is called cubic. You don't really need to know this right at this point, but that's because of the third. This is quadratic. Quadratic. If I multiply this all out, I would wind up with getting x squared, which would be quadratic. And this would also be quadratic because it's a quantity raised to the second power. All right. So notice I now have an exponent that is no longer a number. So my exponent is a letter. Okay, so you have a starting point, which is going to be the y-intercept. So what you basically want to do, the y-intercept is always going to be 0, comma, some number. And then we're going to figure out a second point. That's pretty simple to do. We'll probably plug 1 in to get something. Okay. Notice there's nothing added or subtracted at this point, so that's going to come into play in a second. Okay, so if I put a 0 in, I get 16 times 2 raised to the 0, and we know that 2 raised to the 0 is 1, so I get 16. If I plug a 1 in, then I get 32, and then if I plug a 2 in, that's going to get times 4, so that's going to get a lot bigger. I think it gets 64, it gets bigger and bigger. If I plug a 0 in here, I get 16. If I plug a 1 in here, I get 18. If I plug 2 in here, because I'm just multiplying this, 2 times 2 is 4, so I get 20, and then 22. So it's kind of a gradual growth type of situation. I know that wasn't in the notes. Okay, so we're going to start at the y-intercept, so you're always going to plug 0 in, and then that's going to do it. And remember, a number raised to the 0 power is just going to give me 1. Okay. And then as you go to the right, from A, multiply by B. As you go from the left, divide by B. Well, let's take a look what's going to happen here. Okay, so these are basically growth equations because as I go right, the graph goes away from the x-axis. So as I go this way, I'm going away. One way might be go to the positive and negative. This is, so this would be a growth situation. This would be something called a decay, because as I go right, I get close to the x-axis. All right, so let's see how we can graph a couple of these. Describe the domain and range. Domain and range, let's not really worry about it too much right now, but let's do this. Is there anything over here where I added or subtracted? And the answer is no. So you have something called an asymptote. And an asymptote is something that you can't cross. So the asymptote here is going to be right along here. Okay, it'll be different if I added or subtracted a number to the very end. Okay, now I'm going to plug 0 in to our original equation. So that's going to give me 4 times 2 raised to the 0, which is 4 times 2 to the 0 is 1. So I get 0, 4, which is here. And then let's just plug another simple number in. Let's plug 1 in. So I get 4 times 2 to the first, which is 4 times 2, which is 8. So I get 1 comma 8. So 1, 2, 3, 4, 5, 6, 7, 8. Did I do that right? 1, 2, 3, 4, 5, 6, 7, 8 there. So take a look at this graph. Looks just like that. So you only need 2 points, and just once you see the graph and the direction it goes. Okay, we're going to graph 2 of these at once. So there's nothing added or subtracted to the very end, so they're both going to have an asymptote here, okay, on the x-axis. So let's do this in red. So if I plug 0 in, I'm going to get 2 to the 0, which is 1. So I get 0, 1, which is right here. And then let's plug 1 in. So I get 2 to the first, which is 2. So, oops, 0, 1 went in the wrong spot. I'm sorry. 0, 1 is there. There's my first point. The second point is 0, or 1, 2, which is here. So this graph looks like this. Okay, let's do the other one in green. Okay, so I'm going to plug 0 in. So I'm going to get 1/2 times 2 raised to the 0. Well, 1/2 times 2 to the 0. 2 to the 0 is 1, so I get 1/2. So 0, 1/2 is down here, so it's a little bit underneath there. And then let's plug 1 in. So I get 1/2 times 2 to the first. 2 to the first is 2, so I get 1/2 times 2, which is equal to 1, so 1, 1. So this one is not growing quite as fast. Kind of looks like that. It's underneath it. Okay, so these are relatively simple. Now, when you look at the domain of each of these, let's go back to the domain of this first one on the last page, or the previous problem. The domain of these will go from negative to positive infinity. Let's take a look at the range. Remember, the range is an elevator. So it's going to go from our asymptote, which is 0, to infinity. And that should be the same for both of these. These both have a domain and range, negative to positive infinity, and then our range doesn't go above the x-axis, so it's 0 to infinity. Okay, and remember, that's the y direction. This is the x direction. Okay, let's take a look at these. So again, we're not adding or subtracting anything to them, so I am going to have an asymptote here. Okay, so let's take the first one. We'll do it in red. I'm going to plug 0 in. So I'm going to get 4 times 1/2 raised to the 0. Excuse me. 1/2 to the 0 is 1. 4 times 1, so that we get 0, 4. It's right up there. And we'll do this one in blue. So then I'm going to plug 0 in. Oh, I didn't get the other point. Sorry. So then I'm going to plug 1 in. So I get 4 to the 1/2 times 1. 1/2 times the first is 1/2. So that's going to give me 2. So 1, 2. So look at this one. It kind of goes downward. This is called a decay problem. Okay, we'll do this other one in blue. If I plug 1/2 in, I get negative outside. So 1/2 to the 0 is 1. So I get 0, -1. Look how it's down underneath there. And then I'm going to plug 1 in. So I have the 1/2 out front. So I'm going to get 1/2 to the first, which is 1/2. Again, I give this point up. It's down here. 0, -1's here. And then 1, -1/2 is here. So these are both decay. Okay, and so because they're coming to the asymptote, the x-axis in this case. Our domain, negative to positive infinity, I can plug anything in. My range for the red is going to go from 0 to infinity, but my range for the blue, they're going to both have the same domain, is going to go from negative infinity to 0, the asymptote. Okay, so the difference is they flip over the asymptote in this case. Okay, all right, let's get away from those. All right, so I think you could do page 197 and 198 and do 1 through 3. And then, let's see, then we could do 6 through 12. Okay, have a nice day.